Okie dokie. Let's move on. I'm hoping this is another fairly short, but there's a lot of parts to this problem. It is all linear, so it's nothing really new. So I'm on page 145, number 20. I would recommend pausing me first, obviously, to copy this stuff like always, but also to either, let me think, are you going to have a textbook by now? I believe so. This is weeks into the school year. Again, I'm recording during the summer. You should have a textbook by now, so I think it would probably be easier to grab your textbook, but if not, then open up the PDF and read the problem. I would, you know what they always say, right? They being probably us teachers. Read the problem carefully first and then start thinking about what you're going to do. I remember thinking how tedious that was when I was a student, but it's super important and it's really a life lesson. See, this is the bummer about this. We can't have these like life lesson conversations when we're interacting in class, or like I normally do when we're interacting in class. Maybe we can do that on the Zooms though. Okay, height versus head circumference. Pause me and read that. Okay, so we're talking about a linear model between a child's height and head circumference and the growth rate, right? They're talking about capital H for the child's height and capital C for the circumference of their head. She randomly selects 9 children from her medical practice, measures their height, head circumference, and obtains the data shown. Let H represent, okay, so H is the independent variable and C is the dependent variable. So the question is, which one goes on the x-axis? So hopefully you're thinking that the independent variable goes on the x-axis because that, I don't know why I labeled that, it's habit. I can't draw a graph without labeling the axes. So we normally, when we're making a t-chart, like we did the last time there was a video lesson, which was actually a little while ago, we pick x values, right? Independent of anything else, we plug them in, and the y value we get depends on the x value we chose. Okay, so we want to write head circumference. Oops, not there, sorry. In inches, and then this is height, which is also in inches, right? Now, A says use a graphing utility to draw a scatter plot, so I'm going to show you how to do that. We're just going to sketch it. So we're going to go into stat. Let me move it up so you can see. Stat is right here. And then hit enter to go into these lists. Oh, let me clear out these lists. Don't worry about what I'm doing now because that's old data from last year. Okay, so we want to put in the heights. Hopefully you have a graphing calculator and can do this along with me. If you don't practice during the notes, then it's going to be harder for you to do it in the homework. And then if you don't practice in the homework, then you're probably going to be really stuck on a quiz or a test. This is normally where I would say, somebody let me know if I typed anything in wrong. So I'm going to have to double check really fast. Okay, so I got all the heights in. I'm going to put the head circumferences in here. Okay, let me just double check those. Okay, and then the way that I get a scatter plot, I need to go into stat plot, so hit the second key and then stat plot. Is everybody there? Okay, and then I want to turn it on, so just click enter. So you saw when I first went in here, it looked like this, and this was solid and this was blinking, so it's saying like I can change it to this if I want. If I hit enter, notice that it went to solid there. And then I go graph. Oh, I probably need to change my window. Let me see, it's done graphing. Okay, yeah, so do you see how my x values are between -2 and 6? So I'm not getting any of my data. Go look at the chart again. The data in the x column is all between 25 and 27.75. So I don't want to have my, I don't need any negatives, right? So I'm going to go to 28. My highest value is 27.75. And then my y's go from about, it looks like 16.4 up to 17.6. So I'm going to go up to 18 there. Don't worry about the rest of the stuff. Now hit graph. There's all your data. Now, I don't particularly want all my data clustered up like that, right? So what I'm going to do is I'm going to draw a little and that's kind of indicating that I've scrunched the x-axis. So there's a big portion of the x-axis over here. And then I'm going to start with a higher number right there. So this might be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I start at 11 or something like that. That's all that that's indicating. So let me go back to my window and show, let's see, what did we say the x values were between? 25. So I'm going to go 24 just so I have a clear window. And let me see what that looks like. So this is, I'm just trying to show you, like I could change it all to what it should be without really explaining it, but I'm just trying to show you like what's going on here. I'm just playing with numbers. Okay, so that looks better in the x direction, but now I've got all this white space down here. I need to chop off some stuff in the y direction, right? So I'm going to do the same thing. I'm indicating that maybe this is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, whatever. And then I'm starting with like 15 there or something. That's what that little tick means. So my y values, we said, went from 16.4. So I'm going to go like that. And now I have a better picture of what the data looks like. And I'm literally just going to sketch what I'm seeing. I really don't want you spending a lot of time on this. I just want you to sketch what you're seeing. Okay? I also want you to write your window. So my window in the x direction goes from 24 to 28. And my window in the y direction goes from 16 to 18. Okay? Oops, I forgot my t. Height. Okay, let's see if we can move through the rest of the parts more quickly. B says, use a graphing utility to find the line of best fit that models the relation between height and head circumference. Okay, so let's see if we can do that. Let's go back here. And then we're going to go back into the stat menu. Stat, right there. And then I want to calculate linear regression. It doesn't matter which of these two you choose, but it's just generally more common to go ax plus b instead of a plus bx. Okay, so I want an equation of a line. This is an equation of a line, right? And it says line of best fit. So you got to know that that's linear regression. So I'm telling it that I want the x values in list 1 and the y values in list 2. And then I'm just going to go down and hit calculate. And now it's telling me that the a value is 0.373. I want rounded to 3 decimal places, please. And the b value is 7.327. And if it's y equals ax plus b, then my equation is, oops, I forgot my x. But it says express the model using function notation. So the function notation, normally we say y equals f of x, right? Well, this is a function in terms of c and h. So we're going to go y equals c of h. The x value is h in this problem. And the y value is c. Okay, this, I wonder if I can stop that from doing that without just keeping my hand there. Okay, so we're going to write c of h equals, and that is our equation of the line in function notation. Okay, that was B. C says interpret the slope. Let me show you what that looks like, by the way, on the graph. I'm going to go 0.373x plus 7.327, and I'm going to graph it. And that looks like a line of best fit from what I remember from Algebra 1, right? Okay. C says interpret the slope. Slope is rise over run, yeah? Oh, question, what's the slope? Okay, so the slope is that, because it's y equals mx plus b, right? And rise over run, rise, run. The rise is the change in y. And the run is the change in x, right? Rise is up and down, run is left and right. So I need to describe this in terms of the variables in the problem. So, and it's pretty much a formula here. For every one, what are we in? Inch increase in height, the run, the x value, the head circumference increases 0.373 inches. Remember, the head circumference is dependent on the height. So make sure your sentence reads that way. The head circumference is dependent on the height. All right. Now, the only difference here when you do problems in the homework, you're going to say for every whatever change in x, increase or decrease. Now, we're always going to say increase for x because our denominator is always going to be considered positive. We're always thinking of moving to the right. But sometimes the slope will be negative. So instead of the points going up, the points might go down. So this might actually change to decreases. And then we don't want to have a negative here because if we say decreases and then we use a negative, that's a double negative. And we all know what that means from English class, right? Okay, we're almost done. What are we doing on time? Ooh, can we get it done before 15? Predict the head circumference of a child that is 26 inches tall. Yeah, I'm not even going to do that. We're just going to discuss. Inches tall, that's giving me 26 inches tall is giving me the height. And the height is on the x-axis. So I'm just going to plug a 26 in for the x. For part D. The answer, here I'll give you guys the answers real fast if you want to check, just in case you want to practice. So when you plug a 26 in for x, you should get out 17.025 inches, and this is a word problem, so we're always going to include units when units are given to us. And then E says, what is the height of a child whose head circumference is 17.4? So now they're giving us the y value. We're going to plug in 17.4 and we're going to solve this equation for x. Okay? And for that, you should get 27.005 inches. Okay, okay. Oh, I got to think of a question to ask you guys. For the play pause it. I'll think of something and I'll just add it right here. Okay, have a good day.